Hi there, here's a movie I've been meaning to make for a while, and it's on this product that I bought from Banggood. The link will be in the description, and it's a multi-rotor power distribution board with step down and a filter, which I thought was pretty cool. As we can see, I've gone overboard with the hot glue to make sure all the joints that I've soldered are sort of strong and protected from touching anything. It's going on a quadcopter that has a carbon fiber frame, so I didn't want it to short out on anything. So as we can see, it has a 5 volts, a 12 volts from in, which actually means from the camera, 2 VTX, which is to the video transmitter. I'm assuming it's the 5.8 gigahertz kind of transmitters, because that's what I'm using. And then 2 OSD, and up here from OSD. And there's little solder pads up here which directly relate to this center power pin of the VTX and the camera. It allows you to choose either 5 volts or 12 volts in either of these cases for the camera pin. So if you want to power your camera with 5 volts, you do as I've done here and solder the 5 volts. If you want to power 12 volts, you make the solder across these 2 pads, the center pad and this 12 volt pad, and this will become 12 volts. Same with the VTX, 5 volts and 12 volts for the center one here. I've chosen 5 volts in this one just because I want a 5 volt rail there. The VTX I'm using has a separate power supply, which I would be using maybe up here or from somewhere else. But moving on, the OSD just has the ground and the signal here. So the signal path would go from the camera out of the 2 OSD back in the OSD over here from OSD, and then out the 2 VTX. So kind of from here to here to here to here, sort of connected, and all grounds are connected across the whole board, so you don't need to worry about that. And if you're not doing an OSD, you connect those together, and that, I guess, will short from here to here. So it's all very from here to here. I hope it's all very explanatory. What else? I've connected a quadcopter, so I've got 4 outputs plus 2 sort of auxiliary outputs. I'm actually using a 3S battery on this one, so I'll be getting the 12 volts from these rails here. I'm doing that because once you put 12 volts through a 12 volt regulator, this one or this one, then you don't get 12 volts anymore. But if you're using a 4S battery, which I could use, I've got one here, I'll show you, these will put out 12 volts through here and here, and these will be 14.8 or higher. Okay, so for the first part, we'll have a look at the 4S battery. Here we can see it's reading 16.53, so it's pretty much fully charged, and we'll just plug this into the board. Okay, so I've come up with some nice bright LEDs. Then we'll plug into a ground and a power. And we'll see that these main terminals on the sides push out the 4S full power. Then, because we're using a shared ground, I'll just see if I can't hold one of these down. There we are. Pardon me. So we'll then have a look at the 5 volts. 5 volt line is reading 5.01, pretty nice. And the 12 volts are reading 11.94. It's pretty nice too. This is just a ground and a signal, so we're interested in what voltages come out of here. Now I've soldered the 5 volts and the 5 volts here and here, so this should give us 5 volts. And likewise, we should get 5 volts here. And this one here, which is no specification, is always 5 volts. Now, should I have soldered the other pad here, we could see that that is actually to the 12 volts rail. So when you solder these down, you're soldering between the 5 and 12 volts rail. So it seems to be providing power quite nicely using the 4S battery. Now we are going to have a look at the 3S battery, which is what I'm using, mainly because my motors are only rated for 3S. And my ESCs are strongly recommended to be 3S, and they could use 4 apparently, but they say you need to be careful about the heat generated with the BEC. So anyway, as you can see, 11.84 volts. It's not as fully charged as it could be, but that's okay. It'll do for the demonstration, which I'm about to plug in. And all the lights come on as they were previously. And let me just jump on this and show you that through the side rails, there's pretty much straight through with the 11.8483 volts there. And we can also see that the 5 volts are 5 volts, bit under. There you go, beautiful work. And I don't think it was fluctuating that much. I think it was just me rubbing the thing around. It's pretty solid at 5 volts. Whoops. But we can see that the 12 volts is not quite 12 volts, but considering that the input is less than 12 volts, you know, it's not like we weren't expecting it to have a drop of some. And once again, because I'm using the 5 volts across the board, we can see that we're getting, oh, there we go, 5 volts across everything. So there you go. Still a viable board, and I'm still quite happy with the 5 volts that comes out of it. I just can't use the 12 volt rail because I've got 12 volts on the side, so it's not like it's really a problem. I just can't pull it through my ESC, which is, you know, a limitation of my system. So that's all there is about that. Leave any comments below if you have any questions. Rate and subscribe, and as always, thanks for watching.